Hello everyone. Thanks for joining the call, and we will wait for another 2 more minutes. Then we can start our session. Okay, then I think let's start. Okay. So LLM pen testing series 6. Today's session is the 6th series. In this, we are going to talk about FoolBox. So I hope you are able to hear me, and the screen is visible for you. So just make some confirmations. Okay, great. Okay then. So, about me. My name is Michael Joshua, and the founder and CEO of 𝔽𝕠𝕠𝕝 Cybersecurity. And today's agenda is we are going to see about FoolBox definitions, installation methods, FoolBox attack types, and the conclusion part, like how we are going to use that. Okay, so what is a FoolBox? A FoolBox, it's a Python library that is used for mainly to fool the AI model. Okay, how we are going to, like, so we have seen in the previous series that we try to fool the AI models with the different types of attacks, like text attacks and many more. Like even we try to steal the data from the AI, like whether it's a prompt injection, data poisoning, or maybe the text attacks, different types of attacks. How FoolBox is different from that? So FoolBox, what it does, it creates a small changes to the input data. So what is the input data which we are giving to that model? It's an image. Okay. In that image, we do make a lot of changes. For example, like we are going to see here only 6 types of attacks, but there are more than 10 attacks are there for FoolBox. Here we are going to see how we are using the FoolBox to attack the AI models. So mainly into the images. Okay. So what they mentioned, it is built on top of 𝐸𝐴𝐴. Okay, and it works with the models like PyTorch and TensorFlow and JAX. So installation methods are in such a way. They use a Python -m virtual environment FoolBox, and then it goes for the, these are methods, like you have to install all those environments to install the FoolBox, and you can use those methods. Okay, then okay, so today we will see the practicals as well. Like now we'll see what are those attacks, what are different types of attacks, as well as we will see that how we will be execute each attacks. Okay, first one is FGSM. Okay, before that I want to tell about FoolBox. How FoolBox is about, see, there is a god, you can see, like, there is an organization. In that organization there is a god. What he tries to do, he checks every person in that organization before they enter, like they don't have any ID code or anything else. They're just seeing those faces, and he will allow to the company's premise. But there are certain people in the higher management, they do wear spectacles or some coolers. Okay, so he will allow them according to their appearance. One day, some person from the outside, he's a thief, he wants to enter inside the premise. So what he tries to do, he just wears some obstacles. If he didn't have anything like like a mask, or maybe do some any other changes. Instead of that, he wears some coolers, and then he enters inside the premise, like he wants to bypass the guard. The guard doesn't check him properly. The guard thought that the person is the higher management, let him alone, because his face is similar to those things, because of the spectacles he wears. But the actual people will be able to recognize. Here, the security guard is the AI model. The sneaky glasses, and the glasses which the hacker wears, is the adversarial attacks. The FoolBox is the how we are trying to attack the tricks which the attacker uses, called the FoolBox. Okay, so in that we are going to see each and every attacks today. The first one is 𝐷𝐸𝐴𝐴𝐻 attack. The second one is the second attack is about 𝐿IN-PGD attacks, that is projected gradient descent. Third one is spatial attack. Fourth one is deep full attack. Fifth one is salt and pepper noise attack. Sixth one is Newton full attack. So these are the attacks which we are going to see, theoretical as well as practical, how we are going to fool the AI. Okay, the first method is fast gradient sign method. So far anybody have any doubts? If everything's fine, then I can move for the next one. Okay, great then. So so the first one which we are going to see about is FGSM, fast gradient sign method. This is an attack. What they are trying to say here, they're making some small change in the direction of the gradient sign to the input. The input is the image. We have the image. We add some gradient sign in the input. Along with that, we are sending it to the AI model, whether it can be recognize it or not. Okay, what happens here? Here, for a normal person, like as a person, we will not be able to recognize that. There is no changes. Like see, both are looks like a parrot. There is no change in that. Okay, they have added in small pixel level. They have added into that picture. Once we combine these two things and send it to the AI model, whether it can be able to find it or not. Okay, in that case, what happens? It will not. It will detect that as a wrong one. Okay, it says it's not a parrot. It's a ostrich. It's a something called it's a volcano or something. It has something different. Okay, what we are trying to do here is we are making a small mathematical tweak here in that picture. Okay, the image still looks for everyone it's the same. There won't be any changes will be present, but the model makes a completely wrong predictions. Okay, so we will see how this can be done. Okay, we will see that's a practical one. So before that I want to explain the code to you, how that works. So we are not going in depth detail of the code, since this is a like high level we are going to see. Here I add that image path. If you see that the import FoolBox as FB, this is the FoolBox tool. So we have written a code. In this code, we take the input as an image. We use the model called ResNet 50 model we have used, and the attack which we are going to perform is the FGSM attack. See here, the first one is the image, the signal image, name of the image which we are going to give as input, and the model which we are going to test is the ResNet 50. Whatever model if you want, you can test it by your own. ResNet or maybe like mobile Excel, and so many models are there. You can check what models if you want to test for that. So the attack which you are going to provide is FGSM. Okay, let's see the practical. Okay, Mukesh, please share your screen. Okay, so this is the practical one. This is a program which we have written to use the tools and take the inputs and the model. This is a backend page. So future we will be able to create a front ends as well. Okay, FoolBox as AFP we have declared here. Okay, you can move down. Okay, so now we use the model .ResNet 50. If you see that the model which we have used, we are loading the pre-trained model here. That is called ResNet 50. Then we just wrap the model in the FoolBox interface. For that we use PyTorch model. Okay, then we directly predict the original label. Later we attack the FGSM. Like we are using the FGSM attack. Attack equal to FB. FB is the full box. In that, we have a lot of attacks. In that attack, we use the FGSM, that is fast gradient sign method. Okay, these are the main things in the input and the attack. We are collaborating in a single program. Okay, now we are going to execute it. Okay, you can execute. Okay, so we have executed. See, this is the output of the image. So virtual image which we have provided here is this is the original image to the AI model. Okay, the model name is ResNet 50. We have provided the model, but the model is not resistant to that attack for the FGSM attack. Okay, see here, this is the original image. The right side you see the adversarial image. Its success is true. What it represents means the attack is success. Okay, here we have added some tiny changes. If you see in the bottom, the left side, if you see the output, the original label is 632. The adversarial label goes for 920, and the attack success rate is, it says it's a true. Okay, so in that way, the attack has been success. So this is how the FGSM attack is executed. This model is failed for a FGSM attack. So anyone has any doubt here? Fine. So I'll with that we will move for the next attack. Okay. So far we have seen this attack in the output, and then we are moving for the next attack. What is the next attack which we are going for this model? In the full box, the second attack type is called projected gradient descent. It is called PGD. This is called iterative attack. What is iterative attack? Iteration 1, iteration 2, iteration 3. In such a way, we gradually modify the input. So the image which we have, right? The first attack, what we did, we directly find some place, and then we change the gradient, and then we have an attack. But here it has been changed. It's not like that. It's gradually sense, like slowly we are changing the image module, and changing that by using the maybe in the direction of the loss gradient. So by doing that, there's certain limit. In that limit, the model tends to change. Like it will not be able to identify that. So maybe it's a panda or not. But for a human eyes, it looks like a panda. But how this works at certain point of time, it shows like some other things, maybe like a camel or something else. In such a way, it looks for the AI model. Okay, so what I will say some relevant example to make you to understand here. So that is a metro station. That metro station, that is an employee. In the train, they have a employee's compartment as a passenger. So that is an ID card represented by the employee. What he did is he just show the card to that is a camera. It is connected to the AI model. Okay. So in that, whatever he represents, it checks and see whether the person is authorized person or not. What happens when there is a hacker? He tries to get inside the compartment of the driver, the train driver. Okay. So what he want to do? He just collected the card and the photo ID of that driver. He literally wants to change them. Okay, he cannot enter inside train station. They will be able to identify the other people. Those who are working, they will be able to identify him. What he is trying to do, he picked the driver's photo and he made that badge. Slowly he changed the like the gradients in the inside the photo. But if you see it directly, you will not be seeing. Like slowly he's changing. Like one time he just makes some changes and show it to the AI model. It predicts or not. Okay, it predicted. Okay, then again. Slowly, one by one. That's a gradually he modifies the input until the AI model does not recognize him. Like maybe like that he will be able to fool that AI model. For the real people, those who see the cards, it's an actual person. It's a driver. It's a normal someone from outside. But for the AI model, it seems like he's the driver for them. So that's how they change that the pixel in such a way. Like gradually they just change it. Okay. So in that case, we are going to see this how this attack. Previously, it takes only one time. This time, it makes multiple steps. Okay, for each step, iteration means like one by one. Okay, but that also has some limits. Okay, so actually, what it does, it modifies one area, not the every area. It's like said, there is one area it picks, and then if it checks whether this area will be able to confuse the AI model, or if you want to change another one in such a way, it check until the limit. It has some limit boundary line. Okay, so I have explained this attack. Now we see the practical for this. Okay, here see this is the PGD attack. Like so, we have programmed for each and every attack. So we can do that all the attacks in a one single tool. But for a demo purpose, we have used different programs. Okay, we have created different programs. We utilize the FoolBox. We have already installed. For installation purpose, we have published another video in our channel. If you want, I can put it there. You can see that how we have installed. Installation part, you can use that video. So mostly that won't available in the YouTube. So we have released that one. Okay, the next one is here we have see the first one, like we have used the tool FoolBox as FB. Then we use the model 𝐷𝕚𝕚𝕚, the previous model which we have used, ResNet, which we have used, the same model which we have used here. That is a pre-trained model. You can use whatever model you want to test that one. Okay. Then we use the FoolBox model wrapper. That's we use the PyTorch framework. Then we use the transformers. Then we use the attack. So what attack we are going to use? Just go for the attack. Okay, so lim FPGD attack. So earlier what we seen here, we see FGSM attack. Here we use same FoolBox attack, then lim PGD attacks. Okay, let's see. Let's run this one. That's the only change you have to do to run the different attacks. So now we are running this attack. Let's see how this works. And the same image, the image we didn't change anything. We have used the same image which we have already used, the signal image. Okay, we got the output. Very immediately we got the output. So if you have the GPU or CPU, it will be good actually. It actually uses what it consumes. Like we are used in our laptop itself, it works fine. Certain cases, if you use a huge, bigger models, you need the GPU for that. Okay, with the normal laptops, you will not be able to run. See here, the original image which we have provided is the left one. The adversarial attack is the right one. Okay, so for a human eye, there are no changes. It looks like the same. Okay, we don't see any changes. But for a model, it has been failed. Actually, it identified as something different. If you see that the left one, the output of the command prompt, it says that original class 920. The adversarial class 505. They use the transformers for this. So in that case, if you see, there's a huge difference. The attack success rate, it says that it's a true. Attack success means the attack happened. The model is able to predict that as something different. Okay, so this is how it works. In the attack methods are different here. Okay, if you see something, any model, you have to try each and every method. The first one, FGSM. This one is In this one we use PGD attack. Okay, projected gradient descent. So anybody having any doubts here? Otherwise we will move for the next attack. We'll move for the third one. As like I said, I have mentioned here how we have attacked, what is the output which we get it over here. The third one is something different from the previous two attacks. If you see, the attack name called spatial attack. This is an adversarial attack. What's they are doing something different from the previous attacks. Previous we try to change the image inside, right? Maybe like adding some pixels or adding some something like gradually we add. And the first one we add for FGSM we add only one time. For a PGD we add gradually we just change until we confuse the A. But here in this spatial attack, we're just trying to rotate the image, right? Rotate the image in sense, if you see that the image is in normal way, first one, I try to slightly tilt that to 15 degree, so that the AI model gets confused. Okay, here I'm not adding any small pixel changes, just shifting or rotating or just ups and downs in such a way. How? Because today you see there are cars, like now cars are adding AI models. For example, if you take Tesla models, they might use the AI like autonomous driving. The when the car is traveling in the road, there will be a board sign, right? So in that sign, maybe like something that sign, what happened here is slightly tilted, because of some winds or something. It's a stop sign. It's a stop sign. What happens because of wind or something happened? It just slightly tilted, so that it shows like something 15 degrees slide. But what happened? The car is driving, so parallelly it would capture the image and process that. What's the result? If it's a stop, it has to stop. But the AI model which they use there is not resilient to identify those things, those small changes. It will not stop, right? It will not stop actually. Yeah. It directly, even though it observes that stop sign, it thinks that because it's not in a straight, it's a slightly changed. By observing that, it's keep on driving, right? It won't stop. So what happens? What happens if that kind of scenarios happen? The people will be able. People will cross that streets, or maybe then other cars or any automobiles will just go here and there. At that time, there will be huge accidents will be happen. So that's what we are saying. This spatial attack will be very helpful, and if we find that model is not withstand for this spatial attack, the developer should, what they need to do, they have to rectify the issue and make that model somewhat more secure. Okay. So with that, I just want to explain the code here. Okay, so Mukesh, can you share your screen? See, so yeah, okay. So in this case, so there are other things like spatial transformations. What happened? The researchers from MIT and IBM, they have tested. They have made some. So there are some deep learning models called ResNet, which we are using now. Currently, we are using that ResNet model, and there is another model called Inception model. They train that there is a data sets called ImageNet. Those ImageNets, they just have some small rotations, translation they have used. Like what they did, they go for some 3 degree shift in the pixels, and such a way they have done. After that, they see that the model confused itself. Okay, let's see here. We will run this model. Okay, see here. Okay, so what we have used, the same thing we are using the ResNet module. So these are different tool, like it's a spatial.py we have written. We are loading the pre-trained models as usual, which we say here. Then in the wrapper, please go for the attack. Okay, here The attack which we are using here is spatial attack, FB. FB is like full box. They have already declared that attack equal to FB dot attacks the spatial attack. Here what we did, FGSM we used, and before that we used something different. Okay, PGD such a way we use. We are calling this special spatial attack. Let's see how. Can you move down? It will show the results in such a way. What's the original class? What's the adversarial class, and then whether the attack has been success or not. Okay, you can run this now. Okay, just run this program. We will be able to identify the stability of that model, whether this model will stand for this attack or not. Okay, so the input, this is the image which you have input. The first one is the input image we have given. What happened? This has attacked. The full box attacked in such a way for the model. It's just slightly tilted. If you see that, that's 15 degrees Celsius. 15 degrees has been shifted on the right. And see the output which we have shown here. The original class is 920. The adversarial class is 723. The attack success is true. Yes, this model gets confused because of this attack. So previously what we did, we have slightly changed the pixels for different attacks, like different methods we have used. Here, because of slightly change also. Okay, for example, if you see nowadays in cameras, they are using the, if you see in a parking slots, they have used the camera, they use the AI models. What are the cars and what are the details they capture, whatever they are parking. If you see, if there are any the people, those who want to hide themselves, they what they have to do here, they just take the car and park in a way slightly different. See, if it's parked straight, then the camera will be able to focus and take the car number. But what that guy is trying to do here is he wants to do some kind of spatial attack. Spatial attack is like slightly small changes on the slightly change the direction and stop them. Because of that, the camera will not be able to capture all the details of that car. So only half or maybe like 40% or maybe 50% will be able to capture them. So with that, what happens here? So the AI model gets confused. It might be something different. Okay, in such a way, we have attacked here by just slightly changing the image, because the attack has been success. If it is a fail, it will tell you that it's a false. We'll use the different modules in the upcoming attacks. So you will be able to understand that. So which models can stand for those attacks and which models are not. Okay. So anyone having any doubts? Please wait, Mukesh. Anybody having any doubts here in this spatial attack? Please ask. So all good. Anybody having any confusions or maybe any doubts? Any layman doubts also fine. Okay, fine. So with that, we move for the next attack. So far we have seen 3 attacks in the full box. Okay. Now we moved into the attack called deep fool attack. What is deep fool attack? So here, what that tool deep fool is, what it is going to do with that model is smallest perturbation, that smallest change across some area so that the classifier, who is the classifier? The model will classify which one goes and which one is not. So I will tell you something. So that is ice cream parlor. Okay, the ice cream parlor, they have they are using some AI models. What they are trying to use, that they want to identify which flavor that ice cream. So I have ice cream with me, like one white. How that model predicts those ice creams, like If it is a vanilla, that will be white. If it is a chocolate, then it's a brown. What the attacker here is trying to do here is, so he has ice cream, and with that ice cream, what he is trying to do here, he has a coffee beans, okay, slight coffee beans, and he's adding the coffee beans on top of the, it's like not much, it's only slightly. So what is the motto of this attack is, we are not going to use like lot of changes. We are going to do some smallest changes, very slight changes in that image, so that we are trying to confuse the AI. Okay, what that attacker is trying to do, he used the ice cream, vanilla ice cream, just have some few coffee beans, which represents in brown color. He add on the top of it, small, not heavy, very small, and then he has some brown powder. That's brown powder is like coffee powder, right? Coffee powder. He has taken something, and above on top of that, he has added, not much, slightly. Okay, but as a people, like a normal person, it looks like a vanilla flavor. We don't see huge changes in that. But what this guy is trying to do, to show it to the AI model. Okay, what that AI model predicts that as, it's a chocolate flavor. Okay, so this is how the full attack works. We have the, because we are continuously changing the behavior of the AI model. We have the ice cream with vanilla flavor. By making some smallest changes in the picture, we confuse the AI and make that to predict as chocolate flavor. In such a way, it works. Okay, so okay. So what happens if you see in the there are multiple models. Here we are using the ResNet model. There is we use some CIFAR model. We can use some, there's some data sets. You see model will be there. Data sets will be used to feed that model. Okay, we take some images from the ImageNet or maybe in the CIFAR. Okay, so now what we do, we try to make this tool run. Once this tool runs, okay, so what this does is, it makes some calculated changes here. It makes some calculated changes here, so that it makes the AI confusion. Make it as a confuse and predict that as a wrong. That's a CIFAR or maybe the image. Okay, so with that we see here. See here, we are using the same ResNet model, and then we use the ResNet model here, and then we use the image. If you see the second one, image is same single image. So you can use multiple images. There is no worry there, because here I use only one model, only one image. You can use looping. You can use a loop. You can use 100 images. You try to upload 100 images and test the models. Here we are in the bottom. If you see the attack which I am going to use, the FoolBox attack, L2 deep full attack. I call that attack. Okay, so we have already installed. We have the programs we are trying to use. So if you have a front end, what's the difference, right? We can upload it. So we are working on the front end. It will be simple. Just upload the image. We call that what model we are going to use. Run it. Then it will attack and tell you the result. Okay. Since we are working only on the background, backend, we are showing the codes. Okay, so the image I'm using one. For your flexibility, you can use n number of images. Okay. Okay, then now we are going for the practicals. Okay, Mukesh, please share your screen. Okay, this is the third one which we have worked. Fourth one. Deep full attack. Okay, see the model which we have used is ResNet 50. That's a pre-trained model. It's the same for everything. You can use any models. Here the input, what model which you are going to test, that model you have to use it here. Then as usual, we have wrapped the model with the FoolBox, then go for the attack. So we have used the transforms and everything, transformers, everything we have used here. So this is the attack. See, if you see curiously, if you see that one, see whatever the changes we have made, you will be able to identify. FB attacks, FoolBox attacks use the PGD, spatial, uh, PGD, and then spatial attacks, FGSM. Now we are using the fourth one, deep full attack, L2 deep full attack. Okay, now we are going to run this attack. Just please run that. Python deep.py. Now we run this attack. It's running. Okay, so there are certain attacks which take some time. Okay, not everyone. Certain we see that spatial and then FGSM and all. It suddenly became the results came immediately, but for certain attacks that takes some time. Okay, if you see that 1, 3 to 24, 2 to 4, it's like we have a different types of methods we do use. At the end, you will see the results. Okay, let's wait for some time to get the result. So we have 2 more attacks pending. So we see how the time permits. Yeah, so we got the image. Okay, so the original image is one, and the adversarial image is the next one. We have pushed the adversarial image, but what's the difference here? If you see the left side, the attack success, if you watch that, the attack success is false. Original label is 920, adversarial label is 962. You see that that's the identification number the model has been provided, but what thinks the attack success is false. The model is resilient to that attack. Okay, we made some changes and for all gradients and everything we have done. We have made some changes, calculated change over there, but AI found that no, this is a single image. There is no adversarial image. It didn't confuse. Okay, so previously what we have observed, whatever attacks we run, it was true. Okay, the model has been failed. The same model, the ResNet 50 we have used, the same model is failed. But now what happens? It is success. So the model withstand for this attack. See, the attack success false. The original label is this. The adversarial label is this one. Okay, so great. Okay, you can. With that, we are moving for the next one. Now, very much interesting things which are moving. Okay, the attack name is called salt and pepper noise attack. See, you already heard that, no? In films, people do have the salt and pepper. Salt is for white and pepper is for black. Okay, George Clooney and so many people, they do have a salt and pepper has video call. Right here, what is salt and pepper? How we are going to use that for attack, right? See here in the salt and pepper, right? What happens here? It's add a random black and white in the images. We have an image. In that image, it randomly adds somewhere some pixels. It picks some pixels, adds some black. Means it make the values more contrast. If it takes some 5 pixels and make those pixels increase the value so that it will be more bright, more white. Then it makes add that's a very less. Then what it does, it will be black by reducing those values. By causing this, it makes the classification of the data. Okay. So see here, in the earlier stages, we have a TV. It comes like a popcorn kind of, right? Black and white. In such a way, it actually makes some large noises and make the AI model confused. Okay, let's go into the practical stuff and see how that works. We will show you what will be the output of that. Okay, can you share the screen? See here, so we use the same image and can you put up? here we are using the same image model, ResNet 18 model, and we have pre-processing things, and later what we are using here, yeah. So now we are using the model FB, the FoolBox attack. Go for the attack one. Yes, we use the salt and pepper noise attack. See, everyone has a thing, and also we use the epsilon control noise strengths. So this one will give you the noise, how much noise we are going to put it there in the image. Okay, maybe like no 0.1, 0.3, 0. The strength, the noise strength will be increased, and we check whether that model will stand for those noises. Okay, let's check it out. Okay, so you can run the image. Okay, now we are running this. So we have given the input, that model. Now we are using the salt and pepper. Salt and pepper. See, in salt and pepper, like it won't add any other areas, like specifically in any other areas. It mainly what it does is, okay, just a minute. Okay, so what it does, randomly choose some pixels and add the black and white pixels. So it add a lot of visual noises, but that will be visible to the human eyes, but not for the AI models. Okay, so yes, it is taking some time. Okay, so depending upon the attacks, see here the original prediction here 920, and we are waiting for that. We have sent the arguments and everything. Okay, so it attacks each and every one. The epsilons, like the first one, it makes the attacks like the first salt and pepper, small noise. It increases the noise. It checks whether that model would stand for that attack or not. See here, here in the bottom, if you see that epsilon 0.10 attack, it's a false. False in the sense, yes, the model is stand for this attack. Previously, it has failed for 3 attacks. For the last 2 attacks, this model is withstand. Our ResNet 18 is withstand for the attacks. Okay, means the attack success is not possible, because first one it is 0.110. The attack prediction is same. Adversarial is same. Okay, and then for 0.3 it increases the noise. Then it's the same. For 0.50, then again it's the same. See, if I close it, wait, like so each time the attack, previous one we saw it as 0.1, now it's 0.3. Now just close it. The third attack 0.5, it slightly increases the salt and pepper noises, but the model will stand for that. So the model is not vulnerable to this FoolBox. It is salt and pepper noise attack, it's withstand for that. Okay, you can close it. Okay, so with that we are moving for the last attack, Newton full attack. So we have seen that make some changes in the, so far we have seen 5 attacks. Those 5 attacks we seen that making some changes in the pixels, gradual changes, and then slightly tilt the images, and then we are adding some salt and pepper noise. Now we are going to see the Newton full attack. What is Newton full attack? So it is also iteratively perturbed, means like slowly, like not a one changes. We are making one step at a time. Means one changes at a time in that image. Approximately in the sense like there is some critical position. Till that time, we use the Newton's method, aiming to make some minimal changes. Not we are going to a lot of changes. We do make a lot of changes. The entire image will get changed. So that we are using the tiny changes. We do the tiny changes for previous attacks also, but here we are using the Newton's method to make the minimal changes. At the end, it similarly, like we are trying to fool the AI models. Okay, so for example, I would say that some for your understanding, I would say There's a classroom. In the classroom, the teacher will be there, the student will be there. The student write an exam and send it to the teacher. So that what the tutor is saying, that the tutor evaluate how, if she shows the exact answers which she taught during the session or maybe in the book, if it is present, then she will put the 100% mark. If it is not present, she will not give marks. So what that student, first time he just he observed the evaluation. Slowly he understand the evaluation of the teacher and found that how she evaluating. What he's trying to do, he just change the words, means like he paraphrase the words, but the name is not changed. The name is not changed. He just literally change the words and paraphrase the sentences. Then he sent it to the teacher. While she evaluating, he got the good marks. Now, if you see that, the teacher is the A module, the tutor is the A module, the student is the FoolBox. The tricks are called the attacks. Okay, the attacks, we are using the attacks. How the FoolBox trying to attack? By using the understanding how the A model evaluates. Slowly it sends, it sees how it evaluates, then it changes its method, change its method by slowly using its own mathematical calculation and then attacking the A model. Now after that, finally we do check whether that model is withstand for that attack or not. Okay, now we straightly go for the things. So like here, what the small changes over here, we are using the MobileNet V2 model. But previously we have used the ResNet model. Like ResNet we have used. Now we are using the MobileNet version 2 base. This module is a different image AI model we are using here. And the image which we are using, same image we are not using. So whatever image if you want, you can give it as input as a one image or maybe the multiple inputs you can give it. Then the third attack we are using here is Newton full attack. Okay, now we are going for a practical one. Okay, please share this. Okay, so here see we are using this. See the top we have used MobileNet V2 base. We have changed the model here, and the model we have invoked. The next. We will go for the directly for the attacks. So here we are using the Newton full attack. FB attacks Newton full attack. Okay, you can run now. So you have to write a single code, and that is a slight changes we have to make for the each and every attack. Okay. Yeah. So once we run, we see what will be the output. We have the input, we have the model, we will see for the output. How we just tell the FoolBox use Newton full attack. It may take some time. Let's see how the output comes. Whether this model resilient to that attack or it may fail to that attack. You can see that's a original image. The adversarial image is the Newton full on the right side. Okay. Oh, okay. So unfortunately here the attack has success. Okay. This model withstand for this attack, this Newton full attack. Okay. So if you see the original label and the adversarial label, the image has been changed, but still the AI model is able to identify that. Okay. Even though they make some changes, this model withstand for the attack. Similarly, you can use multiple models. Like we have used two models here. ResNet we have used, MobileNet we have used, two models we have used for testing. You can use multiple models to test these things. So anybody have any doubts for this Newton tool attack? No. In that, I will move. And so far we have covered all the attacks. Okay, you can stop pressing. Okay, what's the real world scenarios? As like I explained earlier, see the stop sign. If you see the stop sign, like Tesla cars, or maybe in many places it is that for a autonomous car, they use a model to identify the images in the streets, whether it's a stop or maybe goes for like right turn or left turn. If that has been changed, then it causes a huge chaos, huge confusion will be present. And if you see that there is another method, I would say that in the medical industry, if you see today what's happening here, we have X-ray. That X-ray model is I just learned by the AI model to identify the what kind of disease the person is having. In that case, doctor get the data through the AI. So what happens? See, if the AI model they are using for the medical purpose is not withstand for this kind of attacks. If you use the FoolBox, it is not withstand for those attacks. If there is a slight change in the X-ray, okay, there is some crack someone is doing. So what happens? The AI model think that there is a crack in the bones. He has to go for a treatment. Maybe like if he has a pneumonia or something. With that small changes, it falls into huge huge repercussions will be happens. Okay, so that's what we have to test using this FoolBox. You can try from your side. If you have any doubts, you can just approach me in the group which we have created. Okay, we have our YouTube channel. Like I have this LinkedIn groups as well as YouTube. You can connect with me anytime. We post a regular topics over here. Like over here, I will take sessions like every bi-weekly, maybe like every 2 weeks once. Regularly, we post a lot of videos in our YouTube handle as well as the LinkedIn. You can connect with us there. So if you have any questions, let me ask. So otherwise, we can wrap up this session. So anyone has any doubts so far? Ram or maybe like another one? No doubts? Okay. So anyway, now we post this recording to you. We can go through it. If you have any doubts, we can come back and ask you. So thank you, everyone. Thanks for your time. Have a great day ahead. Bye then. Take care.